Hello, welcome back to Learn Physics. In today's topic, we are going to discuss about the thermodynamics chapter. That whole chapter, important points I wrote over here, and in that important formulas I should say. All the important points are not there, but important formulas are here. Clear? So first we learned about the thermodynamics, zeroth law of thermodynamics. What is zeroth law of thermodynamics? If A and C are in thermal equilibrium and B and C are in thermal equilibrium, then we can say A and B will be in thermal equilibrium with each other. If A is in thermal equilibrium with C, B is in thermal equilibrium with C, then we can say A and B are in thermal equilibrium. That is about the zeroth law. Next, this first law of thermodynamics. In first law of thermodynamics, mathematical expression we wrote it as dq equals du plus dw. What is dq? dq is the amount of heat energy that is equal to internal energy. The heat energy change is used, the given heat energy is used for changing the internal energy and for doing work. The heat energy absorbed or liberated will be equal to the change in internal energy and the work done. dq equals du plus dw. dw, how we can write down? Work done equals P delta V. Okay, so dw equals P delta V, therefore dq equals du plus P delta V. That formula also important only. Next is Mayer's relation. Cp minus Cv equals R. R is the universal gas constant. Then the different processes. Isothermal process. Temperature is constant. If temperature is constant, that means delta T is equal to, change in temperature is equal to 0. That is, temperature remains constant. If temperature is constant, we can say PV equals constant. If P, see, and dq equals dw. Temperature constant means it is internal energy is the term depends only on temperature. So if temperature is constant, internal energy also will be constant. So change in internal energy will be 0. If change in internal energy is 0, dq will be equal to dw. Therefore, in an isothermal process, dq equals dw. Next is work done. Work done, how we can represent it as RT ln V2 by V1. Natural logarithm, if we are converting into log to the base 10, we can write it as 2.303 into RT log V2 by V1. Okay, so this formula is very important because at the time of deriving your Carnot's engine, we require this formula. Okay, so don't forget to by heart this formula, RT log ln V2 by V1 or 2.303 RT ln log V2 by V1. Okay, next is adiabatic process. What is an adiabatic process? In an adiabatic process, the no heat energy is absorbed or liberated to the system. Okay, that is change in heat energy is 0 over there. That is delta Q equals 0. Or we can write it as du equals minus dw. See, dq is equal to 0. That is du plus dw equals 0. That means du equals minus dw. And here this formula also important. Pv to the power gamma is a constant or Tv to the power gamma minus 1 is a constant. Any one way you can write down. Okay, for an isothermal process, Pv equals constant for an ideal gas, and for an adiabatic process, Pv to the power gamma is a constant for an ideal gas. Okay. Then what is the work done? Work done will be equal to R by gamma minus 1 into T1 minus T2. This formula also you should by heart for the derivation of Carnot's engine. Okay, R by gamma minus 1 into T1 minus T2. Next is equipartition of energy. Energy will be equally distributed. Equipartition, energy is equally distributed. That is, for 1 degree of freedom, energy will be equal to half kBT. Then if it is 3 degrees of freedom, the total average kinetic energy per molecule, that is 3 by 2 kBT. So that is dividing among each and every degree of freedom. So if only at the case of vibrational degree of freedom we will consider it as kBT, since we are considering the sense kinetic energy and potential energy will be present over there, we will be considering it as half kBT plus half kBT as kBT. Otherwise each degree of freedom will be half kBT. Clear? Then next is specific heat capacity. For a monoatomic gas, Cv is 3 by 2 R, Cp is 5 by 2 R, and gamma will be equal to Cp by Cv, that is 5 by 3. Okay, here if you have any confusion, please learn any one. Cv you know it is 3 by 2 R. Leave it like that. Cp minus Cv equals R you know, gamma equals Cp by Cv. That formula also you know, right? Cp minus Cv equals R and gamma equals Cp by Cv. This formula also keep in mind. Now any one of these equation if you are learning, you can write down the rest of the equation using these two. Okay, Cv equals 3 by 2 R for a monoatomic gas. For a diatomic gas 5 by 2 R, and triatomic gas it is 3 R. Okay, the respective Cp and gamma also important values only, please go through that. Next is for a solid, what will be the specific heat capacity? Specific heat capacity will be equal to 3R. Next is for water it is 9R, because since it has 3 molecules, isn't it? H2O, 2 hydrogen and 1 oxygen. So together it is 3. So 9R we will be getting for specific heat capacity. Specific heat capacity of solid is 3R and water is 9R. So here next is for a heat engine. Heat engine we know it is source, sink, working substance, all those things are there, and its block diagram. It is very important for a heat engine block diagram, how it will be. For a heat engine the block diagram can be, you see, this is working substance and this is Q1 and T1, this is Q2 and this is T2. Q1 is here, work is done outside, this is heat engine. If all the arrows alone is opposite, then we can say it will be a refrigerator. This is the block diagram for a heat engine. It is a block diagram for a heat engine. So block diagram for both the cases it is important only. So heat engine, what are the things inside the heat engine? A source, working substance and sink. Source, working substance and sink. Heat engine eta equals 1 minus Q2 by Q1. On how we are coming to that conclusion, because we know it as heat engine efficiency of a heat engine as the ratio of work done per cycle to the energy absorbed, heat energy absorbed per cycle, right? Work done as Q1 minus Q2. So Q1 minus Q2 divided by Q1, we will get it as 1 minus Q2 by Q1. That is work efficiency of a heat engine. So an ideal heat engine is, it is Carnot's engine. Carnot's engine means it's a reversible heat engine. It's a reversible heat engine. So it's an so processes which is happening over there are isothermal expansion, adiabatic expansion, isothermal compression, adiabatic compression. Okay, PV diagram in last video for the time of revision also I explained you what is PV diagram. Okay, isotherm we will say PV diagram, otherwise draw isotherm for a Carnot's engine means that PV diagram only you should draw. Okay, then isothermal expansion and adiabatic expansion. Next is isothermal compression and adiabatic compression. And using the efficiency of this heat engine, this formula only we will be deriving the efficiency of a Carnot's engine. So efficiency of a Carnot, we require Q2 and Q1, which are the isothermal compression is Q2 and isothermal expansion is Q1. Okay, so while deriving this one we require the work done also. So that's why I told you to by heart these two formulas. Okay, in the case of isobaric and isochoric process also we have such kind of equation, but there is no other derivation relating to that work done. Okay, so isobaric means pressure is constant and isochoric means volume remains constant. So here we are not considering those equations, and you can consider, see, using this Q2 and Q1 values while you are deriving, you will get 1 minus T2 by T1. Okay, the final expression for efficiency of a Carnot engine is 1 minus T2 by T1. There also you will be using the equation PV to the power gamma is a constant. Okay, then only you can reach to the final. That in detail we are telling in the regular videos. Okay, next is coefficient of performance of a refrigerator, that is beta. In the case of refrigerator, we will be accepting from the source sink from a lower temperature to higher temperature. We will be absorbing with the help of external agency. Okay, so beta equal coefficient of performance beta equals Q2 divided by Q1 minus Q2, that is Q2 by W, that is the work done, or that is the coefficient of performance of a refrigerator. In between, in second law of thermodynamics is there, that is no process is possible whose sole result is the absorption of heat energy from a cold body to a hot body. So Kelvin statement also there, Clausius statement is there. So those two statements also please by heart. So these are the major topics which is coming under the thermodynamics portion. Clear? So next is for the oscillation chapter. In oscillation chapter, main topic is SHM, simple harmonic motion. About SHM, you should know SHM is a periodic motion. Okay, simple harmonic motion is a periodic motion, but their acceleration is directly proportional to displacement. Acceleration is directly proportional to the displacement, and acceleration directed towards the mean position. Acceleration is directed towards the mean position. See here, y is equal to a sine omega t plus phi. This is the representation of an SHM. Okay, how we can represent the displacement of an object which is moving under SHM. Y is equal to a sine omega t plus phi. If you want to find out the velocity, just differentiate it, and you can write it as a omega cos omega t plus phi. Okay. That one, while rearranging, we will get it as, that is there we will be applying root of sine cos theta equals root of 1 minus sine square theta. Okay, applying that, omega into root of a square minus y square. This formula also you by heart. Next, a equals minus omega square y. Okay, that also important. You can learn that also. Then period, how we can find out? Period equals 2 pi into root of x by a. That is for a simple pendulum, you can remember. T equals 2 pi into root L by g. Okay, displacement divided by g. Length, the T equals 2 pi into root L by g, that formula. Kinetic energy, potential energy and total energy. Kinetic energy is half mv square. What is v? Omega into a root of a square minus y square, right? So, kinetic energy is half mv square. So v equals omega into root of a square minus y square. So here we can write it as half m omega square a square minus y square. Potential energy is half m omega square omega square y square, and total energy will be half m omega square a square. These are the important things which are, you will feel only this much is there in the part of oscillation. No, it's not like that. See, so these are the major topics that you must and should learn. Clear? So next chapter is waves. Their progressive wave, stationary wave, nodes, antinodes, that positions. That is very, very important. So here for a progressive wave, we can represent it as y is equal to a sine kx minus omega t plus phi. Phi can be 0 or cannot be 0. That depends. Y is equal to a sine kx minus omega t. What is k? K is the propagation constant or wave number. That is 2 pi by lambda. Omega angular velocity, that is 2 pi by t, or 2 pi into nu you can write down. Then for a stationary wave means 2a sine kx cos omega t. This is the representation of a stationary wave. So here kx term and omega t term will be separated. Okay, here 2a sine kx is the amplitude. Amplitude of a stationary wave is 2a sin kx. Okay. Then next is speed of a progressive wave. How we can write down? V equals nu lambda or omega by k. From there only we are getting V is equal to nu lambda. Okay. V equals omega by k, and that is equal to nu lambda for a progressive wave. Next is station. For in the case of a transverse wave, V is equal to root of T by mu. Okay, V equals root of T by mu. In the case of longitudinal wave, we will write it as V is equal to root of B by rho. This and all derivation through our dimensional analysis only. Remembering, right? So next is in the case of a gas, we are considering V is equal to root of gamma P by rho, considering it as an adiabatic process. Okay, remembering, right? The Laplace correction over Newton's formula. V is equal to root of gamma P by rho. Newton suggested it as V is equal to root of P by rho. Here we considering it as V equals root of gamma P by rho. Clear? So next is for an open pipe and a closed pipe. So in an open pipe, all the harmonics will be present. 1 is to 2 is to 3 is to 4, like that it will go. But in the case of a closed pipe, only odd harmonics will be present, that is 1 is to 3 is to 5. Closed portion, that is if it is very tightly closed portion, means it will be having nodes will be there at those ends. Okay, open side means it will be antinodes will be there at those ends. Okay, that is here sin kx is equal to 1 maximum, that is antinode. Sin kx is equal to 0 is node positions. And beat frequency, see the frequencies, the waves which are having very close frequencies, closely related frequencies, then those frequencies are superposing each other. Okay, comparable frequency, comparable amplitudes and very nearby frequencies are superposing each other, we will get a beat. Okay, so nu beat, how we can find out nu 1 minus nu 2. So these are some of the important topics from this thermodynamics, oscillations and waves. I think these videos are helpful for you, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.